Okay, so if you would, please kind of, in your brain, separate this unit into solving equations and simplifying fractions. So here, if you see an equal sign for solving equations, and the rules are different when you have an equation. If you have an equal sign, you have much different rules. If you have an equal sign, you can multiply everything by the same number, and it doesn't have to be 1. And that's a very different situation than what we started with, okay, than if you're just subtracting a fraction. I'm not going to do common denominators here. What I'm going to do is clear the fraction. So I want to get rid of the fraction altogether. Because although this unit is all about fractions, it's much nicer if you don't have to deal with it. So let's get rid of them where we can. And if you have an equal sign, you can get rid of the fractions. Okay, so that's enough talk without doing math. What's math? To figure out what you need to do, how to clear the fraction, you need to make sure you know what your denominators are. So I'm going to rewrite and factor my denominators fully. X squared minus 1 is x plus 1, x minus 1. And this 3 doesn't have a denominator, so I'm going to give it a denominator of 1. So in order to figure out how to get rid of your fraction, you need to multiply by your most complicated denominator. Kind of like the common denominator. We call this the least common denominator. So what can we multiply to get rid of everything? Well, x plus 1 and x minus 1. Well, to get rid of our denominators. What can we multiply to get rid of our denominators? As long as I multiply by the same thing to each term, it's legal. So what I'm going to do, my tactic is going to be to multiply each term by x plus 1 times x minus 1, because that will cancel all of the denominators we have. Again, this is legal because I'm going to do it to every term. It's really important that you find the least common denominator. If you ramp up and multiply by too much, it makes it very hard to factor back down. Okay, so here my x plus 1's cancel on the left side of the equation, and I have x minus 1 times 4x plus 1. My fraction with my 12, my x plus 1s and my x minus 1 cancel, which is lovely. I'm just left with 12. And here, 3 over 1, the 1 is not needed. So I have 3 times x plus 1, x minus 1. You're going to need to do some double distributing and combining like terms. You are also going to need to get everything, all your terms on the same side so that you can factor. So go ahead, pause the video, double distribute, combine like terms, get everything on the same side of the fraction. That way you can just check your work as a writer. All right, hopefully you have everything on the same side. I'm going to go ahead and double distribute quickly here. Get back to that easy stuff. Okay, so here I have 4x squared plus 1x minus 4x minus 1. This guy here is x squared minus 1. I know that. So this is plus 3x squared minus 3. And over here, just shorthanding this, 1x minus 4x, that's negative 3x. Okay, now I'm going to get everything on the same side. I like my squares to be positive if at all possible. So I'm going to move my 3x squared this way. Oh, and over here I had 12 and negative 3, so that's going to be a positive number. So that's what I'm going to be bringing to the other side of the equation. Sorry, that got really ugly there, but it's going to be pretty here in just a second. 4x squared minus 3x squared is just x squared minus 3x minus 10. And now let's factor. Don't need to split the middle with this one since we have a 1 in front of our x squared. Two numbers that multiply to negative 10 and add to negative 3 are negative 5, positive 2. And when I set those equal to 0 and solve, I get x equals 5 and x equals negative 2. The thing we have to be careful about, we need to go back and double check our original problem and make sure that neither of those values is going to make our denominator 0. So 5 and negative 2. If we look back here, what can x not be? Well, x cannot be positive 1. X cannot be negative 1. And sometimes factored forms. But since neither of those is our solution, our two solutions are lovely. Two lovely solutions. All right, let's solve one more equation on this video. Number 10 is a word problem, which I like. I know you don't love, but that's okay. We'll work through it together. The sum of twice a positive integer and 4 times the reciprocal of the integer is 9. Find the integer. Remember, integers are whole numbers and they're opposites. Sum, so sum means add, twice a positive integer, so let's make that 2 times x, and 4 times the reciprocal of the integer. Reciprocal means you're going to flip it. It is 9. That's really helpful to put those signs in. Now that plus, that sum is kind of in the wrong place. So what this really looks like is this. 2x plus 4 times 1 over x equals 9. And just like we did with the last problem, if you're working with a fraction, let's go all fractions. So 2x over 1. 4 times 1 here is 4 over x equals 9. And let's clear our fraction. So what are we going to multiply everything by? We're going to multiply everything by x, because x is our denominator. X is equal to our denominator. Again, parse this out in your brain. This is different than finding a common denominator. This is clearing the denominator. And the reason we can do this is because of this equal sign. Equal sign is a game changer. Okay, so first term, I just have a 1 in the denominator, so I have x times 2x, 2x squared. Second term, I have 4x over x. My x's cancel. And on the other side of the equal sign, I don't have the denominator to cancel, so I need 9x. Just like the last problem, we need to bring that 9 over, that 9x over, so that we can factor. Or quadratic formula, if you would like. Subtract that 9x over. And factor master. So, 2 times 4 is 8. Two numbers that multiply to positive 8 and add to negative 9 are negative 8 and negative 1. My first two terms have 2 in common and x. My next two terms have a 1 in common, and I always bring down that negative in the middle. That's going to switch that sign. So that 9. My first set each of these equal to 0 and solve, I get x equals 1/2 and x equals 4. Here's the thing, this problem was all about integers, and integers are whole numbers and they're opposites. 1/2 is not an integer. 1/2 is a rational number, so if this problem had been about rational numbers. So our only answer here is 4. If we go back up and look at our original setup, we know that x cannot be 0 here. So if you're asked, you will be asked for those excluded values. Set that denominator equal to 0. That's your excluded value. Your solution is 4.